Reinforcement learning. Reinforcement learning is another prominent category of machine learning. This learning focus on feedback and experience. In this case, models are trained based on feedback loop and experience. There is no supervisor, rather, it learns from its trial and error method. Closest analogy would be the way human learns riding bicycle. Maybe when you start learning bicycle, it will be a bumpy ride. Sometimes you will fall down. It may give us challenges when we start learning it, but over the period of time, we will learn how to move our pedal, how to move our handles, how to sit properly, how to tilt your body. So every time we face some challenge, we know that okay, this is not something we should repeat. We should try something differently. After a period of time, we'll be comfortable with bicycle and we can run it or we can ride it smoothly. Exactly same thing happens in case of reinforcement learning. Model learns from its interaction with the environment, and after lot of training, it learns what is the optimal behavior. So reinforcement learning is the branch of machine learning where an agent learns to make decisions by interacting with an environment to maximize some notion of cumulative rewards. Now, to explain this, I'll use an example of a grid or maze, as you can see in the screen. It's a simple grid. Before I go to explain how it works, first you need to understand few vocabulary about reinforcement learning. Here I'll go through few key components of reinforcement learning. These components are key to understand, and also these are important in terms of designing to facilitate this reinforcement learning process. First, I'll talk about agent. The agent is the learner or decision maker. It is the entity that takes action to achieve a goal or objective. So in this maze, you see the robot, you can think it as the agent. So in different context, agent could be a program, agent could be a robot, or agent could be something that is interacting with environment and the one that is making the decision. Next, I'll talk about environment. The environment is everything the agent interacts with. Environment responds to the agent's action and provide feedback in the form of states and rewards. So in this grid world, you can think the environment is the entire grid with all this setup and all these rewards, everything together. It is the environment for that agent. Now let's talk about state. A state is a specific situation or configuration of the environment at a given time. It represents all the information that agent needs to make decisions. So state is more from an agent point of view. Whatever it can see, whatever it can interact with, whatever it can understand, and it's about a specific situation or configuration. So in this case, in this maze, you can see there are total 9 states. So every step, agent will move from one state to another state. Similarly, if you are thinking about a strategy game or something, every movement or every action can result into another state. Next thing is action. Actions are the choices available to the agent at each state. Actions are what the agent does to influence the environment. So this is the main interaction with environment, and that's how agent knows what rewards it gets from the environment. Next we'll talk about reward, which is the key concept behind reinforcement learning. We don't have any level in reinforcement learning, but we have a concept of reward. A reward is a signal from the environment to the agent indicating the value the last action taken. So rewards reinforce the agent to take good action and not to focus on bad action. So it's basically driving the agent toward good behavior. Policy. The policy is the agent's strategy for deciding which action to take in each state. It can be a simple set of rules or it can be a complex decision making system. So ultimately, the objective of reinforcement learning is to learn the optimal policy, because policy will tell in each state which is the optimal action that agent should take to maximize its rewards or its cumulative rewards. There are few other important vocabulary like value function, Q function or action value function, exploration, exploitation, transition probability, etc. But at this stage, this is enough to understand how reinforcement learning works. Now, we will take a look at general setup of reinforcement learning and how the actual training process works. We will again refer the grid world for reference to better understand and link all the components. So we have an environment, which is the grid world. We have an agent. Agent starts interacting with environment by referring the policy. So if you think that initial state is at start S1, this is the state where agent starts interacting with environment. Initially, we might have a random policy or some previous policy that we may refer, and agent will take action based on that policy. Now once the action is taken, environment will return the next state and also it will give a signal or reward back to agent. So if you can think of from this maze perspective, agent could be in S1 after it takes an action which is like moving either up, down, left, right. In this case might be it has moved from S1 to S4, which is a right movement, and because of its movement it will obtain a reward -1. So this is a generalized structure for any kind of reinforcement learning where agent will interact with the environment, it will behave based on its policy and act. Environment will return state and rewards. Once environment returns reward and state, algorithm will update the policy based on the state and action taken. This loop will continue till the end of this game. Then this process will be repeated again and again, and previous experience or previous stored information will be used to optimize the policy. Once we have a optimized policy, we will know training is complete, and then agent can behave the optimal way. Similarly, other kind of reinforcement learning training methods, say we want to train the agent to optimize a movement or finding the shortest path, all kind of scenario, this basic structure will work. There could be different algorithms, but this structure is applicable to all of them, and that's how the reinforcement learning algorithm learns. We have a 3x3 grid. It is an environment with total 9 states. Here you can see numbered by S1, S2 up to S9. Here the agent can take 4 action in each of the. So it will start moving. Suppose it moves in this direction and then it goes there. Then this game will end here. We call this one episode, and in this episode agent obtained rewards -1 plus -1 plus -1 plus -10, which is -13. Now again another episode will start from here. Maybe agent will go this side, and then it remembers the last time it went up, so it's not an right way, so it again will start moving from this side, and suppose it again goes here and it tries here, maybe it will move in various direction and somehow it will reach here. So this one episode, and again we will be accumulating values for the overall start to end, and from each state what is the value. So suppose it was in S6, and if it moved from S6 to S9, then the value from S6 would be minus 1 plus 10, which is plus 9. So that way every state will have a value and corresponding action. So it took an action from S6, move right, and it got a value of 10. So we'll have a mapping between this state and action reward that it accumulated. This way we'll be running this multiple times. Agent will try in many of this grid, and ultimately it will come up with the optimal action. In this state will be to move up. If it is in S2, the optimal action will be the from S2 would be to again move up. S3 will be move right, S6 will be move right, and then it reaches the S9. Similarly, if it is in S7 state, the optimal action will be to move left. It cannot move right, it cannot move down, and moving up is also something it will learn that here it is getting negative points, so it should not do this again. So optimal action in S7 will be move left, S4 will be move left. So that's how we will be concluding about reinforcement learning. Agent will get trained, it will learn from its experience, and finally it will come up with the optimal policy. Learning is to find the optimal policy or maximize the reward over a period of time. Reinforcement learning is very important in machine learning, and predominantly it's used for all uncertain environment or anything where the strategy related learning is required.